Yes, recording is started. You can write your roll numbers in the chat box. Am I audible?
Yes, sir.
Okay. I hope the screen is visible now. I think this is lecture number 17, right? And we are discussing different communication technologies. In that, we have discussed BLE, Bluetooth Low Energy, right? So let's take a quick review of the thing which we have studied in last lecture, and then we will proceed for next communication technology, that is Zigbee, right? So this Zigbee we are going to study today, but before that, let us quickly revise. This is Bluetooth, right? So Bluetooth Low Energy we have compared with the classic Bluetooth. In classic Bluetooth, we have three different versions: version 1, version 2, and version 3. Right. So version 1, version 2, and version 3, they are intended to provide a higher data rate. Like version 1 provide 1 Mbps, version 2 3 Mbps, and version 3 54 Mbps. These are classic Bluetooths. But in version 4, we have treated this as a Bluetooth low energy, and the intention to design such a technology is to reduce the power consumption. And here, the data transfer rate is at a second priority. First priority is to reduce the power required by that device, right? So here, if you observe, the data rate is not a concern. They have a data rate of 0.3 Mbps. That's why I told you it's like 300 kbps. And then we have seen a lot of things related with the topologies as well. So piconet, and it is star topology. It's using a star topology. One of the device will act as a master device, and another rest of the devices will act as a slave devices. Then we have seen this connection establishment. In connection establishment, one of the device have to behave as a initiator. Second device will act as a advertiser, right? So advertiser, in short, is going to send the data to initiator. So initiator will act as a master, and advertiser will behave as a slave device. For that, advertiser will send a advertisement packet, and the initiator will accept it with the connect request. After that, master sends a poll, that is another request to get the data. So slave will transmit the data. After that, the master will acknowledge it, right? So this is how the connection is established in BLE. These are the four different states, active states of BLE, that we have seen with respect to advertising and initialization. Protocol stack, this is what we have discussed in last lecture. So can someone tell me what are different functionalities associated with those different layers of protocol stack of this BLE? Quickly, can someone? In short, see, basically this protocol stack is divided into three groups. One is application apps, second is host, and third one is controller, right? So now let us talk about controller. Controller will have this physical layer. In a physical layer, this is responsible for transmission and reception of bits. This Physical layer is responsible for transmission and reception of bits at 2.4 gigahertz radio frequency. That is what electromagnetic radiation is. And at this layer, we said Gaussian Gaussian frequency shift keying is utilized here, right? So GFSK is a shift keying technique used in this physical layer. Then we have direct test mode. This direct test mode is actually allowing a tester to transmit or receive a test packet, right? So this will just send a test packet. If test packet is transmitted and received reliably, then only the data can be transmitted. So that's why this direct test mode is allowed here, right? So the tester can then analyze the packets which have been sent. Then we have this link layer, right? So I told you link layer is very, very critical. The link layer is playing a very important role. So this is most complex part of BLE, and it is responsible for advertising, scanning, creating, and maintaining the connection. Let me repeat, this link layer is responsible for advertising, scanning, creating, and maintaining the connection. Also, it performs a packet structuring. And I told you packet structuring produced at this link layer will have will be of this kind, right? So this is actually a packet structure. This is a packet structure, right? So here we have CRC of 24-bit. Then we have data of variable length up to 296 bits. Then we have length of 8-bit, header of 8-bit, access address, then preamble of 8-bit. So we have seen CRC means it's a checksum that to ensure that a packet is valid, that just indicate the errors if it is there in the communication. Then we have a data, it's a variable length up to 296. Actual data is appended here in this packet. Then we have length, right? So length, it simply describes the total length of payload. Payload means data. Then we have 8-bit header. Header describes the content of packet. What sort of content, what type of data that the packet consists of is described by header. Then we have access address, right? So this access address is to advertise the packet so that the data will be going to its intended user, not to others, right? Because in BLE, it simply broadcasts the packet. So only the person whose address is mentioned in this field, that is access address, only that person will be able to catch that packet. After that, we have preamble. Preamble is to synchronize transmitter and receiver. This is what about the packet, which is done at link layer. If I go back again, host to controller interface, I told you HCI is the short form. It allows host to communicate with the controller. This is first thing. Then it allows the exchange of commands and data between host and controller. And this host to controller will actually act as a bridge between host and controller. Then we have host. In host, we have different layers. Like first one in that is this logical link control and adaptation protocol. This is called as a L2 cap in short. L2 cap. This is what called as a L2 cap, right? So the role of this is to have this multiplexing. So multiplexing is performed at this L2 cap, right? And also it established the logical link. Then we have a security manager protocol, right? So security is the main purpose of this one. Then we have pairing and key distribution are the tasks to be performed by this layer. Then we have attribute protocol, right? So attribute protocol, in short, it is called as ATT. So this ATT is responsible for defining set of rules for accessing the data, right? So this defines how the data can be accessed. Then we have GAT. GAT means graduate attribute profile. This graduate attribute profile is defining type of attribute. So this defines what type of data is to be accessed. Then we have generic access profile, right? So generic access profile, in short, GAP, right? So this it defines how devices discover, connect, and present the useful information. And finally, we have this application layer as similar to that of OSI reference model. At the top, we have application layer model, application layer, whose role is to provide different types of services, uh, who defines the type of services and who provides the services, right? So this is what the function associated with application. So this is all about the thing, all about the BLE. Then we have seen different characteristics. Highlighting characteristics are like its range is 15 meter, output power 10 milliwatt, watt, then maximum current of 20 milliampere, latency 3 millisecond. Topology is a star topology. Modulation technique used is Gaussian frequency shift keying at 2.4 gigahertz. Slip current of 1 milliampere. It's a low cost, low power. Then optional EDR, enhanced data rate, and AMP, advanced MAC physical extensions are provided here, and eavesdrop protection, and it maintain the privacy of a device. Also, adaptive frequency hopping is provided in BLE. These are the characteristics we have listed. Limitations are like larger packet over a small network, complex, short range, and data rate is almost 300 kbps, and these are the applications, right? So all of these things we have discussed in last lecture. So today we are going to talk on this Zigbee. Right. So before I move on, if you have any knowledge of Zigbee, if somebody is using some Zigbee module, you can talk on this. If somebody is using Zigbee protocol, Zigbee module in their automation, or let's say in an embedded system, you can talk on Zigbee. Else, we will discuss this Zigbee in detail. What do you know about Zigbee? Have you heard the word Zigbee ever? What is Zigbee? Of course, it is wireless communication technology, but what exactly is this Zigbee? See, this Zigbee is a technological standard. It is actually a wireless technological standard, and it is designed for sensor network. It is designed for sensor network, right? And I told you it's a wireless communication standard, and most importantly, it is standardized by IEEE 802.15.4. Let me write it here. It is standardized by IEEE 802.15.4. So the things which I'm writing in the chat box, they are very, very important as far as MCQs and that online examinations, everything is concerned. So Zigbee is standardized by 802.15.4. Now the question is, what about Bluetooth? What about Bluetooth? If this 802.15.4 is standardized by IEEE, and this is actually intended for Zigbee, right? So this is the standard for Zigbee. So this Zigbee is 802.15.4. What about Bluetooth? See, you are having a Google in your hand. Search on internet and tell me the answer quickly. For Zigbee, the standard is 802.15.4. What about Bluetooth? Unless you tell me the answer of this, the class will not proceed further. I'm asking you the comparison point. Zigbee आपण जर 802.15.4 म्हणत असू तर ब्लूटूथला काय स्टँडर्ड आहे? What is the standard for Bluetooth?
Eight zero two point 15.1.
Correct. 802 point. For Bluetooth, it is 15.1. Correct. Right. So you should remember these numbers because the MCQs are being asked on these concepts only. Like what is the IEEE standard for Bluetooth? Bluetooth, it's 802.15.1. And for Zigbee, it is 802.15.4. Right. So these are the standardization done for Zigbee and Bluetooth. There are other standards, but we will talk about those standards later on after while discussing Wi-Fi. Right. So this is standard for Zigbee. Zigbee is 802.15.4, and it is created by Zigbee Alliance. Who is the owner of this Zigbee standard? Zigbee Alliance. Right. So Zigbee operates in a personal area network. I hope you are aware of this PAN. Right. So what are different networks that you know apart from this PAN? You might be knowing this wireless LAN. Right. So MAN is also there. Wild area network is also there. Right. So a lot of network and the types are there, out of which personal area network, PAN. PAN stands for personal area network. And for personal networking, you can use the Zigbee standard. This is what suggested here. Zigbee operates in a personal area network, that is PAN. And the device to device network, this Zigbee is used. Right. So it provides connectivity between small pocket devices. It connects this connectivity between small handheld devices. It can control lights, switches, thermostats. Lot of applications, electronic applications, can be controlled by using this Zigbee module. Right. So this IEEE 802.15.4 standard was completed in May 2003. So this is a kind of history. This was completed in May 2003. Right. So somebody ask you when the Zigbee is evolved, you should be able to tell that it's in a May 2003. Zigbee Alliance is the organization defining global standard for this kind of reliable, cost-effective, or you can say low power consumption devices. And it is a standard that define a set of communication protocols for low data rate. So similar to BLE, this is another low data rate standard, right? Because here also the focus is on low power consumption, low power application. So Zigbee is a standard that defines a set of communication protocol for low data rate. Right. So short range wireless networking is also possible with Zigbee. And Zigbee based devices operates in uh, three different communication frequency bands. First one is 868 megahertz. See, if I ask you at what frequency band Bluetooth operates, your answer should be 2.4 gigahertz. If I ask you at what frequency range the Bluetooth operates, your answer must be 2.4 gigahertz. But Zigbee operates in three different communication bands, three different frequency bands. First one is 868 megahertz. I will keep on writing here so that 868 megahertz. This is first frequency band of Zigbee is 868 megahertz. Second one is 915 megahertz is the second frequency band, and the third one is again 2.4 gigahertz frequency band. Right, so Bluetooth operates at only one frequency band, that is 2.4 gigahertz, but Zigbee can operate in three different frequency band at 868 megahertz, second is at 915 megahertz, and third one is similar to Bluetooth, 2.4 gigahertz frequency. So the maximum data rate possible with Zigbee is 250 kbps. This is the data rate supported by Zigbee, 250 kbps. So which one is preferred? So as far as data rate is concerned, BLE or Zigbee? Who transmit at higher data rate? I told you the BLE data rate is 300 kbps and Zigbee is having data rate of 250 kbps, right? So BLE is having higher data rate. Zigbee is having data rate of 250 kbps. Zigbee mainly target for battery powered application, right? And where the low data rate, low cost, and longer battery life are main requirements. The Zigbee devices spend most of the time in the power or saving mode or in a sleep mode. So Zigbee devices most of the time they spend the time in a sleep mode. Then Zigbee standard is specially developed to address the need for very low cost implementation of low data rate wireless networks and with ultra low power consumption. Now here the concept comes called as a duty cycle. Duty cycle. So what do you mean by duty cycle? Can anyone tell? I think you might have studied the duty cycle in various different subjects. What is the formula for duty cycle? What is the formula for duty?
T on upon T on plus T off.
Correct. Duty cycle is equal to T on upon T total. That is T on plus T off. T on upon T total. This is what duty cycle is. Now, why I'm talking about duty cycle right now here in this Zigbee? Because this duty cycle plays a very, very vital role in wireless communication. Right here, we will talk about instead of T on, we will consider device on time, and instead of T off, we will talk about device off time. Right. So the duty cycle is the ratio of time the device is active to the total time, right? For example, if a device wake up every minute and it stay in an active state for 60 millisecond, then the duty cycle of that device is 0.001, that is 0.1 percent, right? So let me repeat, if the device is wake up for 1 minute and in that it will be active for only 60 millisecond, in that case duty cycle will be of 0.1%. And in that case, in such application, the device have the duty cycle less than 1%. It will ensure that the battery will last for, let's say, around a year or a couple of years, right? So you can ensure the battery life of 1 year or 2 year if the device battery, if the duty cycle of that device is less than 1%, right? So coming back to the comparison, this is what comparison I have made here for Bluetooth and Zigbee. So data rate supported in Zigbee, it is 20 to 250 kbps. And the typical range of Zigbee devices is 10 meter to 100 meter. Whereas in a Bluetooth, it's 1 to 3 Mbps and the range is 2 to 10 meters. Whereas in a BLE stands for Bluetooth Low Energy, the data rate is 0.3 Mbps and typical range is 2 to 10 meter. So in case if I want to have a higher data rate, now here I'm addressing three concerns. I'm addressing three different concerns. One is with respect to battery life, second with respect to range, and third with respect to data rate. If I need to send a data at higher data rate, which protocol I should select out of those three? If I'm having an application which need a higher data rate, which need to send a data at higher data rate, which communication technology I should prefer? See, the communication is this comparison is in front of you. If the data rate, I want higher data rate, which communication technology that I should prefer? This is very simple question. Three technologies I have compared with respect to data rate and range. My application demands higher data rate. Which technology, whether I should go for Zigbee or BLE or Bluetooth? Can someone please respond? See, if this is the comparison, Zigbee works at 250 kbps, Bluetooth operates at 1 to 3 Mbps, and BLE provides 300 Mbps, 300 kbps speed. In that case, if my application needs higher data rate, I should prefer this Bluetooth technology. In case I need a higher range, if the range of communication must be high, then in that case I should prefer Zigbee. And if I want to have a lower power consumption device with higher data rate, in that case I should prefer BLE, because the data rate supported by BLE is slightly greater than Zigbee. So I should prefer BLE in my application. So I told you in what condition, what technology is to be chosen, right? So comparison is done. Now coming to the Zigbee now, I told you this Zigbee operates at three different frequency band. I told you it's 868 megahertz. Second band is 915 megahertz, and third one is 2.4 gigahertz. So these are the three operating bands, operating frequency band. But when I say frequency band, it should have some lower frequency and upper frequency, right? So this first frequency band is from 868 to 868 to 868.6 megahertz, right? So lower frequency band is 868 megahertz and higher frequency band is 868.6 megahertz. So can you tell me the bandwidth? I hope everyone know what is bandwidth. It's a difference between higher frequency, upper frequency, and lower frequency. So for the first band, what is the bandwidth? What is the bandwidth?
0.6.
Yes, 0.6 megahertz is the bandwidth. So during that 0.6 megahertz, your Zigbee device can operate. Then second band is at 915 megahertz, but it starts from 902 and it ends at 928 megahertz. So how much bandwidth? How much bandwidth it supports?
26.
26 megahertz, correct. And finally, in a gigahertz, 2.4 gigahertz band, it's starting from 2400 megahertz to 2483.5 megahertz. So how much bandwidth?
83.5.
Correct. 83.5 megahertz will be the bandwidth supported in the third band. Right. So let's proceed with those three bands. First band is at 868 megahertz band, and it is used basically in European country. So it is not used in India for a number of different applications, including short-range wireless networking. The second band, this is at 915 megahertz. This second band and third one as well, that is 2.4 gigahertz, are used for industrial, scientific, and medical applications. So I hope you are aware of this ISM frequency band. So this sort of band is license free. You don't have to pay for that to anybody, right? So industrial, scientific, and medical band, this second and third band is ISM band, right? So this 915 megahertz band is used in North America, and rest of the globe is using 2.4 gigahertz frequency band. I hope it is clear. This 915 and 2.4 gigahertz band, these two bands are ISM frequency band. You don't have to pay to anyone for usage of that. It's industrial, scientific, and medical frequency band. And but this 915 megahertz band is used in America, North America. So if you want to build an application by using Zigbee, you have to operate that Zigbee device at which frequency? It's 2.4 gigahertz frequency band. So I hope my project group members are listening to that. From A division, which project group I have? I think boys group. I think they are not here. Swapnil Darshnale, Gaurav Guruji. Okay, they are not here. So the intention is they are working on a project which have the antenna. They are designing the antenna basically, which operates at this 2.4 gigahertz frequency. So that antenna can be utilized for Zigbee, that can be utilized for Bluetooth, that can be utilized for Wi-Fi. So this way you should understand the need, right? So in India, if you want to have the wireless communication, you should have an antenna that operates at 2.4 gigahertz. Let it be the technology can be Bluetooth or Zigbee or Wi-Fi, right? So in turn, you should operate the device at 2.4 gigahertz. Then only in India the wireless communication is possible. As far as this Zigbee is concerned, this is the range. So even my antenna is working at 2,400, let's say 1 megahertz. It can be used for that communication, right? Now let's proceed further to understand different device type. Before we go for the topology, let me discuss different device types of this Zigbee device. So there are two categories. One is full function device. I will better write it here along with the abbreviation. So full function device, FFD, is the first type of device, FFD, and second one is RFD. This RFD is called as a reduced function device. So there are two kinds of Zigbee devices are present. First one is full function device. Second one is reduced function device, right? So then in a full function device, it is capable of performing all the duties described by 802.15.4. So full function device will be performing all the duties as described by this 802.15.4 means Zigbee, right? So it performs all the duties of Zigbee, and it can accept any role in the network. Any role in the network means it can accept to behave as a RFD or it can behave as a FFD. म्हणजेच FFD जे फुल फंक्शन डिव्हाइस आहे ते डिव्हाइस RFD म्हणून सुद्धा ऍक्ट होईल आणि FFD म्हणून सुद्धा ऍक्ट होईल, right? So basically you can consider this full function device as a master device for wireless communication. Second one is RFD. This RFD has limitations in capabilities. It's have limitations. For example, FFD can communicate with any device in the network. हे जे पहिलं FFD आहे, full function device आहे, it can communicate with RFD as well as it can communicate with other FFDs. But there are limitations with RFD. That's why it is called as a reduced function device. RFD has limitations in capabilities such as this RFD can communicate with only FFD. This RFD can communicate with FFD only. So in the network, you are having two devices, full function device and reduced function device. Full function device can communicate with RFD and it can also communicate with FFD. But RFD can only communicate with FFD. It's not going to communicate with other RFD. It will not talk to other slave device. It will only communicate with the master device. Right? So with this basic understanding, let us proceed to understand the topology. So this is the network topology. Basically, Zigbee uses it supports two types of topologies. One is star topology, second one is a mesh topology, which is shown here. First one is a star topology, and second one is a mesh topology. And we know that in a star topology we have some central hub. We will call it as a PAN coordinator. This is personal area network coordinator. This can be FFD or RFD, right? So PAN coordinator have to be FFD, and other devices, O stands for other devices. It can be FFD or RFD. This PAN coordinator have to be FFD only, right? So FFD is connected to remaining RFDs. This is how the topology works here. Here in case of mesh topology, you have P. P stands for PAN coordinator, and it has to be a FFD. Then we have other FFDs connected with that PAN coordinator and other RFDs connected with that PAN coordinator. But here, in this case or in this case, can you see that the RFD cannot have any other connection with other RFD? बघा, कुठलाच RFD दुसऱ्या RFD सोबत communication करत नाही. So you will not find that communication link here in a star topology or in a mesh topology. In short, let me tell you, full function devices जे असतात ते reduced function devices सोबत communication करू शकतात. त्याचबरोबर ते full function device सोबत सुद्धा communication करू शकतात. पण जे reduced function devices असतात ते फक्त आणि फक्त फुल फंक्शन डिव्हाइस सोबत म्हणजेच मास्टर डिव्हाइस सोबतच कम्युनिकेशन करू शकतात. ते दुसऱ्या रिड्युस्ड फंक्शन डिव्हाइस सोबत कम्युनिकेशन करू शकत नाहीत, राईट? सो दिस इज द फंडा बिहाइंड दिस Zigbee, and these are the two topologies used in Zigbee. Either it will go for star topology, but it should have a PAN centralized coordinator called as PAN coordinator. In both the cases, if you are using star topology or mesh topology, it must have the PAN coordinator, personal area network coordinator, and it will be a full function device. Right, so this is all about Zigbee. Then we have connection, data transfer and all that. So if you have any doubts so far, you can ask. I give you time, 2-minute time. See, when no doubts, that simply means you have understood everything or you have not understood anything. So what should I assume if no doubts? Understood everything or understood nothing?
Understood, sir.
Okay. By having this assumption, I will proceed further because there are limitations. I cannot spend a whole lecture in asking the doubts. So for that, let us move on. Similar to the call establishment procedure in the BLE, here also we have some procedure for call establishment. Hope the screen is visible. Can someone respond? जे लिहिलेलं आहे इथं ते सर्वांना दिसतंय का?
Yes, sir.
Okay. So these are the data transfer methods used in Zigbee. In that, first one is data transfer to coordinator from a device. Now I told you there are a variety of devices. There is full function device, then there is a reduced function device, आणि त्यातल्याच एका full function device ला आपण PAN coordinator असं म्हणतो, right? So there are coordinator and there is a coordinator and there are some devices. So how the data transfer from to the coordinator is happening. So you can observe this first case in which data transfer to coordinator from device is happening, right? So device which want to send the data, it will directly send the data to the coordinator, and coordinator will retransmit the coordinator will revert a acknowledgement packet if it is requested by device in data, right? So in a data, if acknowledgement is expected, then only the coordinator will transmit acknowledgement packet. Otherwise the coordinator will get the data and it will not revert anything. बघा, डिव्हाइसनी डेटा पाठवल्यानंतर जर अॅक्नॉलेजमेंट एक्सपेक्ट केली असेल तरच कोऑर्डिनेटर त्या डेटाला अॅक्नॉलेजमेंट पाठवेल. जर डेटामध्ये अॅक्नॉलेजमेंट एक्सपेक्टेड नसेल तर कोऑर्डिनेटर तो डेटा रिसीव्ह करेल आणि it will not acknowledge anything. This is how the data transfer between device to coordinator happens. Second category, second way of communication, data transfer from coordinator to the device. Now here some things are different. If the coordinator, if the device wants something, if the device wants some data from the coordinator, then first of all the device should generate the data request की मला या टाइपचा डेटा हवा आहे. So device will send the request. Device will send the request to the coordinator. And after receiving this data request, the coordinator will immediately respond ki थांब बाबा मी तुला डेटा पाठवतोय. This acknowledgement is very mandatory. डिव्हाइसनी डेटा रिक्वेस्ट पाठवली की कोऑर्डिनेटरनी त्याला अॅक्नॉलेज करणं गरजेचं असतं. Wait for a moment, I will send you the data. This is what the second signal, that is acknowledgement signal or mandatory signal, means. After that, whenever the communication channel is empty, the coordinator will send the data. The coordinator will send the data to the device. And it's up to the device whether to acknowledge or not. कोऑर्डिनेटरचं काम आहे डेटा ट्रान्समिट करणं, रिसीव्ह करायचं आहे नाही करायचं, इट्स अप टू डिव्हाइस. सो coordinator will not expect any of the acknowledgement. So optionally device can intimate case कोऑर्डिनेटरला डिव्हाइस सांगू शकते की मला जो तुम्ही डेटा पाठवलेला आहे तो व्यवस्थित रिसीव्ह झालेला आहे, बट इट इज ऑप्शनल. कोऑर्डिनेटर डू नॉट एक्सपेक्ट एनी दिस थिंग, right? So this is what kind of acknowledgement device can give. जसं मी तुम्हाला विचारतो समजलंय का, इट्स ऑप्शनल. तुम्हाला मी बऱ्याचदा विचारतो समजलंय का, हॅव यू गॉट इट, इट्स अन ऑप्शनल थिंग. कोऑर्डिनेटर हॅज ट्रान्समिटेड, म्हणजे मी माझं शिकवायचं काम केलं, तुम्हाला समजलंय नाही समजलंय त्याला अॅक्नॉलेज करायचं, इट्स अप टू यू, राईट? सो द रोल ऑफ कोऑर्डिनेटर इज जस्ट टू सेंड द डेटा. Device can optionally acknowledge the coordinator की माझ्यापर्यंत डेटा पोहोचलेला आहे, सांगायचं आहे नाही सांगायचं, इट्स अप टू द डिव्हाइस. बट कोऑर्डिनेटर डू नॉट एक्सपेक्ट एनी अॅक्नॉलेजमेंट. माझं काम आहे डेटा ट्रान्समिट करायचं, मी डेटा पाठवलाय, तो भेटलाय नाही भेटलाय त्याला अॅक्नॉलेज करायचं, इट्स अप टू द डिव्हाइस. Right, so this is how the data transfer from coordinator to device happens. And the last category of is data transfer between two devices. Data transfer between two devices, and it follows the same way which has happened in point number 1. Manjes data transfer between coordinator and device, the way in which it happens, the same way is followed in the third category, that is data transfer between टू पेअर डिव्हाइसेस. म्हणजे डिव्हाइस टू डिव्हाइस डेटा ट्रान्सफर होणार असेल तर हा जो फर्स्ट पॉइंट आहे याच्यामध्ये जसं आपण दाखवलेलं आहे कोऑर्डिनेटर टू डेटा अँड दिस डिव्हाइस टू कोऑर्डिनेटर डेटा ट्रान्सफर, इन द सेम फॅशन डिव्हाइस टू डिव्हाइस डेटा ट्रान्सफर इज हॅपन्ड, राईट? सो तिसरा आणि पहिला पॉइंट सेमच आहे, पण इथं काय होत आहे, डिव्हाइस टू कोऑर्डिनेटर डेटा ट्रान्सफर होत आहे, आणि इथं तिसऱ्यामध्ये काय होणार आहे, डिव्हाइस टू डिव्हाइस डेटा ट्रान्सफर होणार आहे. अदरवाइज द मेथड इज सेम. I hope you understood how the connection is established, how the data transfer is possible in Zigbee devices. Next point is protocol stack. Next point is a protocol stack, but it requires more time, and around 4 to 5 minutes are remaining. It will not be possible to discuss this entire Zigbee protocol stack. जसं मी ज्या वेनी ब्लूटूथ साठी डिस्क्राईब केलं होतं, द सेम वे आय एम फॉलोइंग फॉर झिग्बी. जसं मी त्याची इंट्रोडक्शन, त्याची कनेक्शन एस्टॅब्लिशमेंट सगळं तुम्हाला सांगितलं होतं, कुठल्या फ्रिक्वेन्सी बँडला ऑपरेट होतो, कुठला मॉड्युलेशन टेक्निक यूज केलं जातं. इन द सेम वे we are talking about Zigbee. Why I am doing this? Because at the end we should be able to compare BLE. We should be able to compare this BLE with Zigbee. We should be able to compare this BLE with Wi-Fi, right? So in the same pattern, I'm teaching you the things. I'm teaching you those 4 technologies: BLE, Zigbee, Wi-Fi, and RFID. Right? So that's why I told you, you will not find those points, these things anywhere in the book. आणि तुम्हाला दिसत पण असेल, मी हे सगळं स्कॅन करून ज्या नोट्स मधल्या डायग्राम्स आहेत त्या तुम्हाला दाखवतोय, बिकॉज these diagrams are not at all available on the internet. You will not find the source of these data on the internet. You will not find it in any of the book. That's why I'm recommending you to refer the notes. Yes, anyone want to speak? So let us stop here for today. In the next lecture, we will discuss the protocol stack. If you have any doubt, you can ask. Otherwise, you are allowed to leave the meeting. मोठे सरांचा स्पेशल कॉल आलता स्कॅनिंग साठी.